So hello everyone, my name is Akshat Kumar Verma and welcome to the YouTube channel of Developers and Coders Club and IIT Agartala. So today we'll be discussing this problem that came in Code Forces round 754 Division 2, and the problem is problem number B, reverse sort. So this is the problem statement. We read it first and try to understand what it says. So Ashish has a binary string S of length n that he wants to sort in non-decreasing order. So what is non-decreasing order? It basically means the increasing order where like duplicates are allowed. So he can perform the following operation. Okay, so first operation is choose a subsequence of any length such that its elements are in non-increasing order, basically in decreasing order with with repetitions allowed. So formally choose any k such that 1 is less than k is less than n, and any sequence of k indices. Okay, so we can choose any sequence of k indices such that it is in non-increasing order, which is basically this part. Okay, so reverse this subsequence in place. Now, what does in place mean? We'll discuss very soon. So, when we can formally swap Si1 with Sik, that is, we will reverse this subsequence. All right, this is basically reversing this subsequence. So, find the minimum number of operations required to sort the string in non-decreasing order. It can be proven that this is always possible to sort the binary given string. So, we'll also try to prove this part. Okay. So, first we'll take an example. Like an example string is this one. Okay, and its output is what? Its output is this is first we will check the first example. It is already sorted in non-decreasing order, that is increasing order. All the zeros come first and all the ones come second, so its output will be 0 in this string. Okay, they will make only one reversing, only one operation will be made with what? 1, 3, 4 and 5 indices. See, the output is like this, the minimum number of operations in the first line, and then m line should follow. For example, this is m and then one line follows, where first line will where the first character will contain the number of indices that we are reversing, or the number of the size of subsequence, basically the size of subsequence and the indices of subsequence in the original string. So these are the indices 1, 3, 4 and 5. We will look at, so 1 0 1 0 0. Okay, so this is the string. We will write it 1 0 1 0 0. Okay, so it says us 1 3 4 and 5, 1 3 4 and 5. So what is the subsequence 1 3 4 5? It is basically 1 1 0 0, right? And then they say to reverse it. We'll reverse it first, 0 0 1 1, and they mentioned that we have to reverse it in place. Now what does in place mean? Basically, after reversing it, we'll place this string as in the original array, as the original string. So we will only replace these characters in 1 3 4 and 5 positions. So let us replace this. It will come in first position, so it will become what? 0. Second is as it is. Okay, third one we have to replace with this 0. Okay, fourth one we have to replace with this 1 and 1. So this string is now sorted in non-decreasing order, basically increasing order. So this question is this part is done easily. So now similarly for this string, they choose 3 5 and 6 indices. What are 3? This is 3, these are 5 and 6. So basically the subsequence become 1 0 0, and then we reverse it, it becomes 0 0 1, and finally the string becomes 0 0 0 0 0 1. In this test case, we could also have chosen just this index and this index, that is the subsequence will be of 1 and 0, that's all, and then we reverse it and put it in place, so it will become what? 0 0 0 0 0 1. So we could also have done it in like two steps. So it was mentioned that we don't have to minimize k or anything, we just have to minimize m. Okay, we don't have to minimize k, so therefore this output is also valid, and the one I talked about is also valid. Now let us first make some observations. Okay, so it is a binary string and you want to sort it in non-decreasing order. Non-decreasing order basically means increasing order. Okay, so this is the increasing order. Let's say we are proceeding with 0 0 0. Now if any 1 comes, 0 can't occur anymore, because we are trying to make it in non-decreasing order, right? Non-decreasing order basically means increasing order with allowed repetition. Okay, so in non-decreasing order we can't allow any zeros after this one. It will be like this. So the string will be basically all the zeros first and all the ones in the second part. So this will basically be the non-decreasing string we want. This very simplifies the things very much for us. Now we'll also make some more observation, like we have to reverse the subsequence in place. Now, if these are not sorted, like for example, we take this string 1 0 1 0 0. This is a random string that I'm trying to make. Okay, so definitely, clearly, this is not sorted in a non-decreasing order. Now, what we have to do is put all the zeros first. Okay, so this is the result that we have to make in the end: 0 0 0, and then 1 1 1. Right? This is basically on decreasing order that we discussed, that all the zeros first and on the one second. So we have to tell them how many operations will we take for this. And the operation basically means choosing a subsequence and reversing it in place. Now what if I choose the subsequence like this? Okay, first I will choose this one, and I choose these two zeros. So what will it make? If this will make a subsequence, it will make a subsequence like 1 1 0 0, and we reverse it, it will become 0 0 1 1. Okay, now this is done. This is our subsequence. Now if we replace it in place, it will become 0 0 0 1 1 1, and hence our string is sorted in non-decreasing order. Now one more observation I would like to make using the first observation that we made, that the string will always be in the form of all the zeros first and all the ones in the second place. Now if I compare this string with this string, and I say that in my subsequence I will take all the numbers which are in the wrong place. So one is it in its wrong place, I will take it. Okay, I will make an array of solutions. Okay, I will make an array of subsequence. Okay, so this is our subsequence. So if I will take 1, the index 1. Okay, then 0 is in correct place, I won't take it. 1 is it in the wrong place, right? So I will take this index 3. 0 is in the wrong place, I will take this index which is 4. 1 since 0 is again in the wrong place, I will take 5. So basically, if I take this subsequence and reverse it in place, then the subsequence will become like this, right? Because for every 1 present here, there must be a 0 present here for the string to become in non-decreasing order. Because definitely, otherwise we won't be able to sort. Like we want to sort like all the zeros first and all the ones in the second part. So if any one comes here, then we have to put it in the second part. In the second part, definitely it's a binary string. So definitely, if there's not a 1, there will be a 0. And if there's a 0 and it's in the wrong place, we'll just swap them. This is the basic intuition of the problem. So also we can always take like this, that any number which is not in its correct position, we'll just push it into this subsequence array, and at the end we will just output the subsequence array. So basically, every binary string can be sorted in this manner in only one step. In only one step will be what? That choosing all the indices that are in wrong order, that are not in its correct place, and will output that whole array. So I hope that proof is clear to you. It was also written that it can be proven that it's always possible to sort the given binary string in at most n operations. Now we are not even taking n operations. It has been proven that it can be sorted in at most one operation. Why at most? Because like it can also be sorted and just it can all like it will be given to us sorted only. So we don't need to make any changes. It will be 0 or 1. So that's it. That will be our two answers, 0 or 1, because for every 1 present in its wrong place, there must be a 0 which is also present in its wrong place. Otherwise the string would be like this: if 1 is present in its wrong place, then it must be a 0 present in the wrong place as well. So this was the basic intuition of the problem. Now I would like to show you the solution that I have made. So during the contest I have made all these 4 submissions. This was made after the contest. Okay, so this is the code for it. So first I was given the number of test cases in the input. You can see the first line contains n and then the binary string. So that's what I have done, like taken the input n and taken the input of a string, and then I've checked if the string is already sorted, right? If the string is already sorted, for example in the test case 1, it was already sorted in this order, we don't need to do anything and just output 0 and continue with our next test case. So that's what we have done here. And now for checking if the every element is correct order or not, we copy the string first to a different string, we sort the string, and after sorting we'll output 1, because it was given that first we have to output how many number of operations are we taking, basically the value of m, right? So this is the value of m, and now this is the vector of indices that we need to output. So for uh, each element in the original string, I will traverse and check if it is not in its correct position, Then I will push back this index. Index is what one based indexing we need to output. So I will push back 1 plus I into this answer. Answer basically has the subsequence, we can say. Then I will output what the size of it, because we need the output in that order, that we first need to tell the size of it. So this will output the size of it, and this will actually output all the elements of that array. And then in the end we will need to output an end line. Okay, so this was the code that I submitted afterwards. I could also show you a different code that I submission that I made during the contest. This also uses the same approach. It's basically a different one, a bit complex implementation. This was the simplest implementation that you will get, and this is a bit complex implementation. In this, what I did was I kept on swapping. I will show you in the whiteboard. I kept on swapping 0 and 1s from here until, for example, I maintained 2 pointers. One was starting from here, one was starting from here, and now I kept on swapping zeros and ones until these 2 pointers collided. So okay, so this is the while loop for it. This is, see this, in this for loop I create those two arrays of zeros and ones. Okay, and in this array, in this while loop, that's what I am doing, that maintaining 2 pointers I and j, and inserting all the like swapping elements, the indices of all the elements that I swapped into this set. And in the end, if set is empty, basically it means that the string was already sorted in increasing order or non-decreasing order, whatever you want to say. And else I will output 1 and then the elements of the set. And I have not used an unordered set because we needed to output all the indices in increasing order. It was given to us. Okay, this was, see, I1 is less than I2 is less than IK. Okay, so I made use of a set for that purpose. This is basically it's the same idea, but a different and a bit complex implementation. This was the easiest implementation that we can make of it. So thank you everyone. If you have any doubt, you can post it in the comment section, and also you can post it in the Discord. Thank you so much. I hope you liked this video. We'll meet you in the next video. Thank you.